Welcome to this video. In this video, we'll be looking at the concept of aromaticity. When we're talking about aromaticity is a special stability in some cyclic molecules such as aromatic compounds due to the delocalized electrons in their ring or in their structure. Now, the basic concept is that we are looking at aromatic compound, but we know that not all cyclic compounds are aromatic. So that brought us to the classification of aromaticity. When we are talking about the classification of aromaticity, we have that aromaticity or classification of, let's say, cyclic molecules. Now, first thing first, we have the aromatic compounds. The aromatic compounds there. Second of all, we have the anti-aromatic compounds. And third, we have the non-aromatic compounds. Now, this is the three classification of aromaticity. In this video, we are just going to be looking at some basic compounds, and we are going to be checking out if these compounds are either aromatic or anti-aromatic or non-aromatic. Now, the basic understanding is that since aromaticity deals with aromatic compounds, now what are the conditions or what are the criteria for a cyclic compound or for a compound organic structure to be aromatic? Now let's look at the conditions for aromaticity. Now, when we say the conditions for aromaticity there, we have that the first one, the compound must be cyclic in nature. That is, it must have a ring-like structure, or perhaps benzene-like structure, if not benzene. Now, the second case there, that it must be planar. Planar in the sense that it must be what? Flat. The structure must be flat. Now, one key hint for us to know whether a structure is flat is that any cyclic compound that has carbon atoms from 3 to 7 are always flat. That doesn't mean the compound or any cyclic compound that has a number of carbon atoms above 7 are not planar. They can be planar or they cannot be planar, but anyone within the 3 to 7 are always planar. Now, the third one we are going to be looking at is conjugated carbon atoms. Now, this is very interesting. For conjugated carbon atoms, what it means is that in that cyclic structure, in that cyclic planar structure, all the carbon atoms there must at least be attached to a double bond, or must at least have a a lone pair. In the case that we will only have sp2 hybridization. So what they are just trying to say is that if these carbon atoms, or if any atoms, sometimes we could have a case of heterocyclic hydrocarbon or heterocyclic aromatic compound. For this case, we have the presence of either nitrogen or sulfur or oxygen. Now, for all these kind of cases, you'll be seeing lone pair there. Now, this lone pair, whenever the lone pair is within or is facing inside the structure, you count it as part of the pi electrons, but when we get to the last one, you understand what the pi electrons are. And if it is facing outside, that is not in the ring, you do not count it. Hence, at the beam we have something S, and the lone pair of electrons are facing outside the ring. We do not count it. Hence, that atom is not conjugated. Now to the last one, an aromatic compound must follow a rule known as the Ockel's rule. Now when we say Ockel's rule, the Ockel's rule for aromatic compound, says that for it to be an aromatic compound, the number of pi electrons must be 4n plus 2. That is 4n plus 2 pi electrons. But for anti-aromatic compound, it will be 4n pi electrons. Now the basic difference between aromatic compound and anti-aromatic compound is that aromatic compound tick everything here. Everything from the first to second to third, while anti-aromatic also tick first, second, third. They are cyclic, they are planar, they are conjugated. But when it comes to this Ockel's rule, that's what differentiates an aromatic from the anti-aromatic. But a non-aromatic compound, they are not cyclic, they are not planar, they are not conjugated. They do not even follow any of these rule. That's the concept there. Now that's everything we should know. Now let's do something. Let's do some mathematics. Now if we, from this, for the rule for aromatic compound, if we say we substitute n equals 0 or 1 or 2 or 3 and so on, you will see that we'll be having something of 2, 4, and we'll be having something of, so that will be 2, because if we substitute 1 there, we'll be having 6. If we substitute 2 there, we'll be having 10. That's 10 pi electrons. If we substitute 3 there, we'll be having 3 times 12. That's 12 plus 2. That's 14, and so on. So that's the idea there. But for this anti-aromatic, if you check it out, if you substitute n equals 0, 1, 2 or 3, we'll be having something like 4, 8, 12 and so on. Because if you substitute 4 in this n, you'll be having 4 times 4, which is 4. If you substitute 0 in this n, you'll be having, so like if you substitute 1 in this n, you'll be having something like 4, and if you substitute 2, you'll be having 8. But if you substitute 0, you'll be having 0. But the main thing you should know is that for aromatic compound, if you get to calculate the total pi electrons within the structure, and it is either 2 or 6 pi electron or 10 pi electron or 14 pi electron, you should know that that compound is an aromatic compound. But if you get to calculate the total pi electrons and you notice that it is 0 or 4 or 8 or 12, you would know that it is what anti-aromatic compound. Now the funny thing is that if you notice, the pi electrons is just even numbers. Now if you notice, if you check the first one for anti-aromatic, we have 2. The first one for aromatic, we have, if you check the first one for anti-aromatic, we have 0. The first one for aromatic, we have 2. So it's more like changing from 2 to 4, from 4 to 6. But just know these values there, Now let's move to the main business, which is identifying whether structures are aromatic or anti-aromatic or non-aromatic.